For 2.0, example 2, we're looking at factoring, specifically using the sum and difference of cubes. And for letter C, we are going to attempt to factor a 40 x cubed plus 135. First step in factoring should always be to factor out whatever's in common. So take a look at your terms, see if there's anything in common. 40 and 135, those are both divisible by 5, and there isn't anything else in common. So I am going to be able to go through and do a little bit of factoring to start with. I'll be able to factor a 5 out in front. If you want to show a little bit of work with that, you could divide each one of these by whatever that common factor is to help you figure out what goes in the parentheses, but you wouldn't have to show the work on that. Definitely could do that in your head or with your calculator and not show work. That would be fine. 40 divided by 5 is 8, so if I take a 5 out, we would have an 8, and then our x cubed. Then we have our addition symbol, and then 135 divided by 5, that is 27. So if you factor a 5 out in front to get started, your common factor, step number 1, we end up with a 5 out in front and then an 8x cubed plus 27. This 5 is done. We're just going to keep writing that down as we go through and do the problem. It'll be a 5 out in front in our final answer, but we do need to go to step 2 and see if what's in parentheses is factorable. I have two terms. That tells me I need to take a look and see if we have a difference of squares or a sum or difference of cubes pattern. And I see that we do have an addition symbol and that both of these are perfect cubes. Let me erase this 5 out of here so that it doesn't clutter up the rest. And then I will go through and do what we did in letters A and B. I have an 8x cubed here. I know that's a perfect cube because 8 is a perfect cube and x cubed is also a perfect cube. 8 is 2 times 2 times 2, and x cubed is x times x times x. So if I look at three things that are exactly the same that multiply together to give me an 8x cubed, that would be a 2x times another 2x times another 2x. So write those up above, the 8x cubed. 27 is 3 to the third power, so up above the 27, I'm going to write down that 3 times 3 times 3. Still have this 5 out in front, and then we are going to have our binomial and our trinomial using the sum of cubes pattern. I take one of each of these and put it in the first set of parentheses, so a 2x and a 3. Again, in between here is going to be either a plus or a minus, but I will use the acronym SOAP when I'm done coming up with all 5 terms to determine what that is. As you go through and do this, you certainly can put the plus or the minus in there right away if you recognize what it's going to be. The 3 terms that go here in the parentheses, we get those by pairing up those 6 values at the top and multiplying each pair together to get the 3 terms that go in that second set of parentheses. So a 2x times another 2x, that's our first pair. That gives me a 4x squared. Our second pair is going to be the last 2x with the first 3, and 2x times 3 is 6x. And then finally the last pair to get the last term in our trinomial is the 3 times 3, which gives me a 9. And then, using the acronym SOAP, I should be able to get the pluses and minuses in. S stands for same. Originally that was a plus, so I'm going to use the same symbol here. So it will be a 2x plus 3 in the first set of parentheses. O stands for opposite, and the opposite of addition is subtraction. And then finally are always positive, or always plus for that last term. Everything that I have there in black I need to see from you as far as work goes. All the rest of the colors, those are extra things that you could include, but you certainly would not have to. Have one more of those, and then we are done with notes for sum and difference of cubes. For letter D, we're going to take a look at a 3x cubed minus 75. With our 3x cubed minus 75, we're going to start where we always start. Factor out the common factor first. 3 does go into 75, so there is a common factor of 3 here. So I'm going to be able to factor a 3 out in front. If you would like, you can show a little bit of work by dividing each one of these by 3. That will help you figure out what goes in the parentheses here. 3x cubed divided by 3. 3 divided by 3 is 1, so those 3's would cancel. That would just give me an x cubed. And 75 divided by 3 is 25. So in the parentheses, I end up with an x cubed minus 25. After you factor out the common factor, you should take a look at what's in the parentheses here, count how many terms there are, and determine if we can do some more factoring by using one of the other factoring methods. With 2 terms, I know I have 3 options: difference of squares, or sum or difference of cubes. This is subtraction, so maybe this is difference of squares, or maybe this is difference of cubes. Or maybe it's not factorable at all. We'll just have to check that out and see. X cubed is a perfect cube, but 25 is not. 25 is not on our list over here. 25 happens to be a perfect square, but x cubed is not a perfect square. So we check to see if they are both squares, and they're not. We check to see if they're both cubes, and they're not. So we can't do any more factoring at all. That is our final answer. The only thing we could do is factor out a 3 in this problem, and then this does not fit any of the different factoring methods we have for binomials. This is not a difference of squares pattern because x cubed is not a perfect square, and this is not a difference of cubes pattern because 25 is not a perfect cube.